Hey, good to see you again as we go into this video, which is all about integration by parts when we have multiple steps to deal with. Oh my goodness. It's not that bad. It's very natural. It's very intuitive. We're also going to then go over an alternative way of doing things with what is called the table method. It's not so bad. All right, let's jump into this. So it says find the integral x squared times sine x. Again, we identified that there's a product. We have a cyclical function in sine x. We have a function whose derivative will get simpler. So this will be u and this will be dv. And so we'll use by parts as our diagnosis of what to use. So u is equal to x squared. Du is equal to 2x. Very nice. And then, of course, we already selected dv is equal to sine x dx. Very nice. Very nice indeed. And v is going to be equal to the antiderivative of this, which is minus cosine x. Now, something interesting happens here. Remember that our formula is u times v. So this integral simplifies to u times v, or expands out to, minus x squared cosine x. And I'm getting minus x squared from the minus on the cosine, u times v. Minus the integral of v du. So that's going to be 2x times a minus cosine x. That's going to end up being plus. And I'll go over that in just one moment. So I've done v du in the integral part. V is negative cosine x. It changed the minus into a positive. Then we have 2x cosine x. So we look at this antiderivative and we think, well, it's better than this was. We don't have as high a power, so it's getting simpler. That's a good sign. But we're not quite ready to take the integral of that just using a power rule or our trig rules. We have to use by parts a second time. No problem. So we do it again. And so u, again, should be 2x. The reason why that should be 2x is because its derivative will get simpler. And good things will happen. Du is 2 dx. dv is going to be cosine of x. The antiderivative of cosine of x dx is equal to sine of x. That's very nice. All right, so we do it again. Now, don't forget about the minus x squared cosine x. It's still very much a part of things. We're manipulating this antiderivative right here. So this is all equal to minus x squared cosine x plus u times v, which will be 2x sine x, minus the integral of v du. So it's minus the integral of 2 sine x dx. Isn't that pretty? So now we've gotten to the point with a repeated usage of integration by parts where we now can integrate this, and none of these take any action. So I'll copy everything else and evaluate that relatively simple antiderivative. We get minus x squared cosine of x plus 2x sine x minus, well, the antiderivative of this is going to be 2 times a minus cosine x. So that's minus 2 cosine x. Now, minus a minus is a plus. You're going to end up with plus 2 cosine x. So make sure to keep your sign straight. Plus c. All right, so that's one way of doing things. There's another way, and it's known as the table method. Now, I tend to advise people only to use the table method if there's 3 iterations, 3 times through of by parts or more. So this was x cubed. But I want to show it to you with the 2 steps so it makes sense. It's relatively simple. Only use it if you have multiple parts, though. So here's what we do. You're still picking your u and dv parts. That doesn't change. So you set up the table. You have your u value. You have your dv value, right? You start out with that like normal. And we alternate signs. It goes plus, minus, and it just keeps going on and on and on. And I'll tell you how we know when to finish our table. So your u is picked the same way. It's still x squared. Your dv is still picked the same way. It's sine x. And now what we do is the same thing we always do with u. With u, we continue to take derivatives, right? X squared, 2x. So that's its derivative. Just take derivatives down the line. And you know to stop the table when you get down to 0. That's how you know when to stop, quite literally. And then dv, the antiderivative, just like we were doing before in this process, we go dv to v, is going to be minus cosine x. And then the antiderivative of cosine x is minus sine x. So that's minus a minus sine x, which is going to be, the antiderivative of cosine is going to be sine x with that minus there. So that'll be minus sine x. And the antiderivative of that, well, the antiderivative of sine is minus cosine. But you got that minus there, so it's going to be positive cosine. You can check these answers by taking the derivative. and seeing that the derivative of each of these going backwards gets us back to each of those previous values. So that's it. You're still going in the same order that you would when you would divide parts. Derivatives of u, antiderivatives of dv, and knowing to stop here when it's 0. The last part that we do is pretty cool. We set up our products. I'm going to show you why this works momentarily. First, I'm just going to show you the process. You take the plus sign, right? It's like plus 1 times x squared times minus cosine x. So that's minus x squared cosine x. Oh, exactly what we got there, right? We expect. Minus 2x times minus sine x. Everything gets multiplied, so that's minus a minus is a plus 2x sine x. Pretty sweet. Exactly what we got there. And then finally, our last line is 2 times cosine x. Exactly what we got there. And don't forget about plus c. And if it's a definite integral, you'd evaluate the definite integral at this point. That's it. So that's the table method. It's great for repeated uses of integration by parts. Here's why it works. When we're looking at this, right, what we found first was u times v minus integral v du. This is u times v, right there. Then we do minus the integral of v du. Well, since we're doing it again, that integral of v du, which was right here, ends up being another integration by parts. So this is the new u, and this is the new dv, as we saw that, u dv. And so we end up doing u times v in the next part, u times v. And that's why we multiply those. And we go down a level here because it's u times v. And then we do it again where we have the integral and that u value in v du, and that's just 2 times the antiderivative, which is exactly what this is right here. We stop because the next line would be 0 times the number, so we know we're done. Isn't that cool? So that's the table method unearthed, like why it works. You can use it for multiple step problems. I'll put one in the exercises where it's more than just 2 steps, but it's a great technique if you have multiple steps. But if you have 2 steps, I usually stick to integration by parts. All right, that's enough of me yapping. I'll see you in the next video. It's going to be a good one. Until then, peace.